Alright, in this video we're going to take a look at the order of operations. So what does that mean? Well, we're talking about math operators, and we're talking about multiplying, we're talking about dividing, we're talking about adding, we're talking about subtracting. There's raising to a power. So we have exponents, taking square roots, that sort of thing. These are all operators. And they have a precedence in which they need to be accomplished. And those on high have decided that operations in parentheses should be done before exponents, which should be done before multiplication or division, which should be done before addition or subtraction. And there's kind of a nifty little mnemonic. We have parentheses, exponents, multiplication, division, addition, and subtraction, or PEMDAS as it's called, or please excuse my dear Aunt Sally. There's a little acronym for you to remember, or mnemonic. This is the order in which to accomplish the operators when you see more complicated problems. If I have something like 2 plus 6, and I'll use that silly little symbol. It's not really an operator. Okay, we have a series of operations. Where do I start? And this is why this order of operations exists. So it says to accomplish anything in parentheses, then accomplish anything that requires exponents. Then the next two, multiplication and division. Well, years ago in the strict order of operations, we were told to do multiplication before we do division. However, with the advent of the personal computer, which has been around for a long time now, and because of how computers and algorithms for computers are written, they decided that these are on the same level, and to do multiplication or division, depending on which one you come to first in the expression, alphabetically, or not alphabetically, but operation-wise. So if I get multiplication first, do that. If I get division first, then do that. Then do multiplication. So that order is interchangeable. Same thing with adding or subtracting. Okay, so the only order operators that we have here, we have addition and subtraction and division. According to PEMDAS, I need to do the division first. But let's see. I think I'm going to change this value a little bit. Before we do that, I want to make this come out even. Let's put a 3 here. Now, street smarts might just say, okay, well, let's just start at the left and go to the right. So we get 3 plus 6 is 9. So we get 9 divided by 3. That equals 3 minus 1. So we get a grand total of 2. Now, that's certainly an answer. Is it the correct answer? Well, according to the order of operations, there runs a pretty high risk that it's not. All right, let's do it in order of PEMDAS here. This says do the division first. So I'm going to take the 6 divided by the 3, and that's going to give me 3. So I now have 3 plus 3 minus 1. So this operation right here has been done, and it reduces to 3. So 3 plus 3 is 6, minus 1 gives me 7. There's a big difference between 2 and 7. Doing the order of operations is the method that you need to do it in, and that's going to be expected in any branch, field, or whatever on the planet that is doing any kind of mathematics. Okay, this is the order. Now, what if you're putting together expressions, or maybe somebody else has, and writing a complicated or where you're doing multiple steps in the expression, a much better way, instead of depending solely on PEMDAS, is to use some parentheses. Because notice that's the first thing. So let's say I have our 3 plus 6 divided by 3 minus 1. And let's say, well, in what I'm trying to get across when I'm making up this expression, what I want you to do is I want you to do the addition first and the subtraction, then do the division. So now I can add these two together, and I get 9, and I get 2, so this gives me 9 halves. Not a very satisfying answer since it's an improper fraction, but that's okay. We could call that 4.5. But I can direct you to do it in this order. Now, oops, got to get the eraser here. The real problem here is in the originator, me in that case. In writing this out, I should not have written it this way in the first place, because by definition, the operator for division is either the fraction bar or the division box, because both of these are signs of grouping, and parentheses are also used to group operations together. I could have simply written this as 3 plus 6 divided by 3 minus 1. There's no ambiguity in the order here. I must accomplish what's up here and down here before I do the division, because even though they're invisible, this is a sign of grouping, and that's really what this represents. So I get to the same place. This would have been a more intelligent or more intuitive way to write the problem in the first place, instead of doing this simple, stupid little symbol. This is appropriate for on the key of a calculator when you're talking about division, but it sucks as an operator. It's ambiguous. There's no sign of grouping here. Okay, enough of that. So anyway, the order of operations, this is what it is. You can probably remember PEMDAS, or certainly please excuse my dear Aunt Sally, and that tells you the order. And actually, when you're solving algebraic equations, sometimes you have to do one kind of out of order, depending on if parentheses, depends on how much work has been done in the original equation. If the author of the original equation has left you some algebra to do before you solve the equation, then this comes into play big time. Okay, but you're not going to encounter that on tests. All right, that's it for the order of operations. See you in the next video.